All right, let's dive in. Today, we're tackling something a little different. We're building a bridge, you could say, between Python and PHP 8. I know, learning a new language, it can feel like starting from scratch. But I think you might find this transition smoother than you think. You sent over some materials, and honestly, some of the similarities between these two languages are pretty surprising.
Yeah, there are definitely some misconceptions out there about both Python and PHP. One of the biggest ones is this idea that they're purely interpreted languages. In reality, both of them actually go through a compilation stage before your code runs.
Oh, interesting. So it's not just line-by-line interpretation like I always imagined. What's actually happening in that compilation step?
Well, let's start with Python. When you hit run, the interpreter first does a quick syntax check, and if everything looks good, it compiles your code into bytecode. Think of bytecode as like a lower level representation of your code. It's platform independent, and it's actually stored in those .py files you might have seen around.
So it's like a middle step, translating my human-readable code into something the machine can understand better.
Exactly. Then the Python virtual machine comes in, interprets this bytecode, and finally spits out the machine code that your CPU can actually execute.
Got it. So how does PHP handle this whole compilation thing? Is it similar?
It's surprisingly similar, even down to the terminology. PHP's engine, which is called the Zend Engine, takes your code and breaks it down into tokens, like words in a sentence. And then it arranges these tokens into something called an abstract syntax tree, or AST. It's basically a hierarchical map of your code.
Like a family tree for my functions and variables.
Perfect analogy. And from there, the engine compiles your code into opcodes, which are PHP's version of bytecode. Those opcodes are then interpreted by the Zend engine and translated into machine code.
Wow, so both languages have this hidden compilation step. It makes you realize there's a lot going on behind the scenes before your code even starts running.
Absolutely. And speaking of things happening behind the scenes, PHP 8 actually introduced a feature that can significantly boost performance, especially for tasks that are heavy on the CPU, the JIT compiler.
Hold on, a JIT compiler in PHP, that's kind of blowing my mind. I always associated JIT compilation with languages like Java.
It was a major addition to PHP 8 and a real game changer for performance. What's fascinating about the JIT compiler is that it actually analyzes your code at runtime, constantly looking for opportunities to optimize things on the fly. It's like having a dynamic optimization engine built right into PHP.
So it's not compiling everything up front, like in some languages. It's being more strategic.
Exactly. It might notice that a function is being called repeatedly, or a loop is running thousands of times, and decide to compile those hotspots directly into machine code. That can lead to some pretty impressive speed improvement.
Okay, this is really interesting. Coming from Python, I'm used to dynamic typing, where I don't have to declare types explicitly. Does PHP work the same way?
Yes, dynamic typing is another core similarity between the two. Both languages figure out the data type of a variable at runtime, which makes the initial coding process a lot faster and more flexible.
I do love the flexibility of dynamic typing, but I've also learned that it can lead to some tricky bugs if you're not careful. What are your thoughts on that?
Yeah, you've hit the nail on the head. The trade-off with dynamic typing is that you gain development speed, but you need to be extra vigilant about potential type-related errors that might pop up later on.
So for our listeners out there who are Pythonistas venturing into PHP, be mindful that this similarity in typing comes with the same responsibility to write clean, well-tested code.
Now let's talk about some of the differences that you might encounter when making the switch from Python to PHP. One that often catches Python developers off guard is the way code blocks are defined.
Oh yeah, I remember staring at my first PHP code block like it was an alien language. Where did all the indentation go?
It's definitely a jarring difference if you're used to Python's reliance on indentation to structure code. In PHP, we use curly braces to mark the beginning and end of blocks, and each statement ends with a semicolon.
It felt like my brain was short-circuiting the first time I saw that. All those years of meticulously indenting my Python code suddenly felt, well, irrelevant.
It really highlights a fundamental difference in philosophies, right? Python enforces readability through indentation, while PHP opts for these explicit delimiters.
So, dear listener, get ready to embrace the curly braces and semicolons. It might feel a bit odd at first, but you'll get used to it.
Another area that often trips up Python developers is case sensitivity. In Python, everything is case sensitive, but PHP, well, PHP likes to keep us on our toes.
Oh, tell me about it. This one got me more times than I'd like to admit. I'd spent hours debugging, only to realize I'd called a function with the wrong capitalization.
It's a bit of a mixed bag. Variables in PHP are case sensitive, so my variable is different from my variable. But when it comes to function and class names, case suddenly doesn't matter as much. It's like PHP has a mind of its own.
For anyone coming from Python, this is a major gotcha to watch out for. Don't let those seemingly minor capitalization differences slip by. They can cause some serious head-scratching moments during debugging.
And then there are constants, which add another layer of complexity to this whole case sensitivity puzzle. Constants defined with the define function are case sensitive by default, but you can actually make them case insensitive. On the other hand, class constants are always case sensitive.
So as if variables and functions weren't enough, now we have to remember different case rules for constants. It's like PHP is testing our attention to detail.
It definitely highlights the importance of establishing clear naming conventions and really understanding these nuances. You can't just assume things will behave exactly as they do in Python.
All right, listeners, I think we've uncovered some critical differences already. It seems like case sensitivity, or the lack thereof, is something to be extra mindful of when switching from Python to PHP.
So let's move on to another area that might feel familiar but has some subtle quirks, and that's error handling. In Python, we're used to those try-except blocks, for gracefully catching and handling exceptions.
Yeah, try-except blocks are a lifesaver. You try some risky code, and if an exception pops up, you catch it and handle it without, crashing the whole program.
Exactly. PHP uses a very similar mechanism, but with slightly different terminology. Try-catch blocks. But the concept is the same. You try code that might throw an error, and if it does, you catch it in the catch block. You can even have multiple catch blocks to handle different types of exceptions, just like in Python.
So the structure is basically identical, just different keywords. That makes sense. But what about those situations where you don't want to handle the error right there in the code? In Python, I often raise exceptions to signal something went wrong and let the calling code deal with it.
Good point. PHP has a similar concept using the throw keyword. You can throw an exception object, which might contain details about the error, and then handle it somewhere else in your code.
So it's like passing the buck up the chain of command.
Precisely. However, here's where things get a bit more nuanced in PHP. Along with traditional exceptions, PHP also has this concept of errors, which are handled differently.
Hold on. Errors are different from exceptions. That's a bit confusing coming from Python, where exceptions are pretty much the go-to for error handling.
It's a distinction that can definitely trip up Python developers. In PHP, errors are more like warnings or notices. They might signal that something isn't quite right, but they don't necessarily bring your whole program to a screeching halt.
So they're like minor hiccups that PHP can usually work around.
Yeah, you could say that. And PHP gives you a lot of control over how these errors are handled. You can use the error reporting function to decide which types of errors are displayed or logged. You can even set up custom error handlers to deal with specific errors in your own way.
So there's a lot of flexibility there, but also a lot to learn. For our listeners, I think the takeaway here is that while error handling in PHP shares similarities with Python, there are these subtle differences to be aware of.
Now let's circle back to the JIT compiler for a minute. I'm eager to dive a little deeper into how it works and what kind of impact it has on real-world PHP performance.
Yes, let's get into the nitty-gritty. It sounds like a game changer, but I'm curious about the specifics.
Okay, so picture this. Your PHP code is running, and the JIT compiler is like a hawk, watching every move, analyzing how your code is being executed. It's constantly looking for opportunities to optimize things on the fly.
So it's not compiling everything up front. It's being selective about what it optimizes.
Exactly. It might notice that a particular function is being called over and over again, or that a loop is churning through thousands of iterations.
And then it swoops in and compiles those hotspots directly into machine code for a speed boost.
You got it. That's the magic of JIT compilation. It can significantly improve performance, especially for computationally intensive tasks.
But you mentioned earlier that JIT is turned off by default in PHP 8. Why is that? If it's so great for performance, why not have it on all the time?
That's a good question. The truth is, JIT compilation does add some overhead because of the runtime analysis and compilation process. So for some applications, especially those that aren't CPU bound, the overhead might outweigh the performance gains.
So it's not a one-size-fits-all solution. It depends on the nature of the application.
Precisely. It's about finding the right balance. If you're dealing with code that's heavy on number crunching or complex calculations or repetitive operations, then enabling JIT is probably a good idea.
So it's worth experimenting with and seeing if it makes a difference for your specific project.
Absolutely. One of the great things about PHP is its flexibility. You can tweak the JIT settings, test your code's performance, and find what works best for your application.
So for our listeners who are excited to give JIT a try, how do they actually enable it? What settings do they need to change?
It's all controlled through the php.ini file, which is the configuration file for PHP. First, make sure the opcode cache is enabled by setting opcache.enable to 1. Then you'll need to allocate some memory for the JIT buffer by setting opcache.JIT A good starting point might be 100 MB, but you can adjust it based on your needs.
Okay, opcode cache enabled, JIT buffer allocated. What's the final step?
Lastly, you need to turn on the JIT compiler itself. This is done by setting the opcache.JIT directive. There are different levels of optimization you can choose from, but a good general-purpose setting is 1255.
Got it. So tweak those settings, restart the web server, and let the JIT compiler work its magic. I'm definitely going to experiment with this.
Now, let's shift gears a bit and talk about managing external libraries and dependencies. In Python, we have the wonderful pip, which makes installing and managing packages a breeze.
Yeah, pip is a lifesaver in the Python world. It makes managing dependencies so much easier.
PHP has a few popular package managers, but the most widely used is Composer. It's similar in concept to pip, but with some PHP-specific twists.
So I can use Composer to pull in external libraries and frameworks, just like I do with pip in Python.
Absolutely. Composer lets you install packages from a central repository, manage dependencies, and keep everything up to date. But Composer takes things a step further. It uses a file called composer.json to define your project's dependencies and other metadata.
So it's like a blueprint for my project, specifying exactly what packages and versions it needs.
That's a great way to put it. You list the packages, their versions, and any other constraints in this file, and Composer takes care of the rest. It downloads, installs, and manages everything for you.
That sounds pretty similar to how pip uses requirements.txt in Python projects to keep track of dependencies.
The underlying idea is very much the same. Now, one key difference between Composer and pip is how they handle auto-loading.
Auto-loading. I'm not familiar with that term. What does it mean?
Auto-loading is a mechanism that lets you use classes and functions from external packages without having to manually include their files in your code. It's a huge time saver and helps keep your code cleaner.
So it's like telling PHP, hey, if you come across a class from this package, just go ahead and load it automatically. I trust you.
Exactly. Composer does this by generating an autoloader file that maps class names to their file paths. This means you don't have to worry about including a bunch of files at the top of your scripts.
That sounds incredibly convenient. It's like having a personal assistant for your code, making sure everything is loaded and ready to go.
It's one of those features that you don't fully appreciate until you've lived without it.
So for our listeners who are used to pip's simplicity, rest assured that Composer offers a similar level of convenience in the PHP world.
Now that we've talked about managing dependencies, let's move on to a feature that's crucial for keeping your code organized, especially as your projects grow larger. And that's namespaces.
Yes, namespaces. In Python, they're a lifesaver for avoiding naming conflicts and grouping related code. It's like having separate folders for your classes and functions.
Exactly. And the good news is that namespaces in PHP work very similarly to how they do in Python.
That's a relief. So how do they work in the context of PHP?
Just like in Python, PHP namespaces provide a way to organize your code into logical groups, preventing collisions when you have multiple classes or functions with the same name, but from different sources.
It's like having a filing system for your code, making sure everything is in its proper place.
The syntax for defining namespaces is pretty straightforward. You use the namespace keyword, followed by the namespace name and a semicolon. For example, you might have namespace myProjectUtils at the top of your file.
Okay, so it's a simple declaration at the beginning. And how do you actually use a class or function from a specific namespace?
You use the backslash operator to separate the namespace name from the class or function name. So if you have a class called myClass inside the myProjectUtils namespace, you would refer to it as myProjectUtils myClass.
It's like specifying the full path to a file, making it crystal clear where that class is coming from.
And just like in Python, you can use the use keyword in PHP to import a namespace or a specific class from a namespace. This saves you from typing out the full namespace every time.
So it's a convenient shortcut that makes our code more concise and readable.
Absolutely. And speaking of readability, let's transition to a topic that's near and dear to any Python developer's heart: web frameworks.
Ah, yes, web frameworks. The battle of the titans, Django, Flask, Pyramid, in Python. What does the PHP world have to offer in this realm?
PHP has an equally impressive ecosystem of web frameworks, each with its own strengths and philosophies. Some of the most popular ones include Laravel, Symfony, CodeIgniter, and Zend framework.
Wow, so there's no shortage of options in PHP either. It seems like both languages have really embraced the power of frameworks.
Definitely. And just like in Python, choosing the right framework depends on the specific needs and scale of your project.
Could you give us a quick tour of some of these PHP frameworks and how they compare to their Python counterparts?
Sure, Laravel is often compared to Django. It's a full-featured, opinionated framework that provides a lot of structure and conventions out of the box. It's known for its elegant syntax, a powerful ORM for working with databases, and a robust ecosystem of packages.
So if I'm coming from Django and looking for something similar in PHP, Laravel might be a good place to start.
Absolutely. On the other hand, if you prefer a more minimalist approach, like Flask, Lumen might be more your style. It's a micro framework built on top of Laravel, designed for speed and simplicity.
So Lumen is like the Flask of the PHP world, lightweight
Uh-huh.
and perfect for APIs or smaller applications.
Exactly. Now, for those who value flexibility and a more modular approach, Symfony is an excellent choice. It's often compared to Pyramid in the Python world. It allows you to pick and choose the components you need.
So if I enjoy the flexibility and control of Pyramid, Symfony might be right up my alley.
Right. And for beginners or those looking for a more gentle learning curve, CodeIgniter is a solid option. It's easy to learn, straightforward to use, and provides a solid foundation in PHP web development.
It sounds like a great stepping stone into the world of PHP frameworks.
It is. And finally, we have Zend Framework, a veteran in the PHP world. It's a comprehensive and mature framework, well suited for enterprise-level applications with a focus on performance and security.
So it's like the battle-tested, reliable workhorse of PHP frameworks.
Exactly. So as you can see, both Python and PHP offer a diverse range of web frameworks to suit various needs and preferences.
This has been an incredibly insightful journey. It's fascinating to see how these two languages, while distinct in their syntax and quirks, share so many fundamental concepts and approaches.
And with the advancements in PHP 8, like the JIT compiler and improved type handling, the gap between Python and PHP is becoming even narrower.
So for all our Python-loving listeners out there, don't be afraid to take the plunge into PHP. You might just discover your next favorite language, or at the very least, expand your programming toolkit and horizons.
Absolutely. The journey of learning a new language is always rewarding. You'll gain new perspectives, appreciate different approaches to problem solving, and who knows, you might even find yourself falling in love with the quirks and nuances of PHP.
Well said. And as a final thought for our listeners, I'd like to leave you with this. Both Python and PHP have come a long way, borrowing ideas and features from each other along the way. Do you think this cross-pollination of concepts will continue, leading to a convergence of programming languages? Or will each language forge its own unique path?
It's an intriguing question, and one that I'm sure will continue to spark debate and innovation in the programming world. So keep exploring, keep learning, and most importantly, keep coding.